All right. Good afternoon, everybody. Thank you for joining. I hope you've had a good start to your day. Today, we're going to be doing a SimpliPhi 101. This is kind of a overview of our company, our history, where we've been, where we're going, and our products, as well as some best applications for each product. My name is Matthew Walker. I'm the trainer here at SimpliPhi Power. Just to start out with a few housekeeping items, this presentation is NABCEP credited, so if you need credits, I'm going to have my email at the end of the presentation. Just shoot me an email sometime today and ask for credits, and I will send them over to you. Make sure to put your full name in that email so I know who to send the credits to. If you have a question during this training, just go ahead and type it into the Q&A bar. There's a little bubble down at the bottom for questions. You can type them in there. I cannot unmute you, but I will do my best to get to all the questions at the end of the presentation. Awesome. Well, without further ado, I will go ahead and get started with today's content. Thanks again for joining. So to begin, just a brief overview of our company and the history of our growth. We were actually founded in 2010 as OES Energy. So we were born into this mobile application market, developing we were developed as a solution to unsafe lithium chemistries. And specifically, we developed a power pack that could be used in Hollywood filmmaking scenarios. So we really proved our roots in what is, my opinion, one of the most difficult applications, mobile applications, and also proved that we could solve the issue that lithium chemistries had at that time, which was, and still is, that there's many unsafe lithium chemistries out there on the market being used. So after overcoming that, and also providing a solution to the limitations of lead-acid batteries, we then expanded into residential and military and emergency response applications. At this time, the military really did not even want to consider lithium batteries for their applications because of the safety concerns. So we proved to them that LFP batteries, lithium iron phosphate, were safe enough to meet their needs. And they didn't just take our word for it. They did tons of rigorous testing at their different locations, one of which happens to be Aberdeen Proving Grounds, which is actually pretty close to my hometown. We also introduced the Jenny units that year, and those are still, I see tons of them in use for emergency response. People use them for camping and all sorts of cool stuff. And in 2013 and 2014, we began expanding our product line, really focusing on installers and customers, right? We're trying to bring distributed assets to a whole bunch of people, and we want to make sure they're installer friendly and user friendly. So in 2015 and 16, we actually relaunched as SimpliPhi Power, and now we are ramping up manufacturing at our Ventura County, California facility. That's where all our batteries are produced in California. To briefly touch on standards, these are increasingly important as we see jurisdictions adopting newer and newer code requirements. UL is a third party that creates testing standards. They perform tests and they certify products as safe. So these certifications are mostly based around fire safety and disaster safety. So 3 applicable certifications for batteries are 1642, which is cell level, 1973, which is module level, and 9540, which is kind of a system level certification, making sure that all the components in the system are able to safely work together. 9540A, this is not a certification, but a test protocol, and we see it being adopted more and more here. It's more about a system's response to a thermal runaway event. So that is something to keep in mind, is what codes your jurisdiction needs, noting that generally our batteries and solutions are up to date with the newest codes and standards. If you're not sure what UL certifications are needed for, and this is your first time hearing about UL, they're generally, well, they're always going to be needed where this system is inspected or where the building codes are going to be enforced. Even if they're not, even if you think, you know, I've got an off-grid property, nobody's going to be looking at it, I'm not selling it anytime soon, there's no inspectors coming in here, no appraisers, then you still want to think about insurance purposes and really just general best safety practices, making sure you have a product that's been certified as a third party is safe. So as I mentioned a couple slides ago, we were founded as a solution to a problem. And at that time, the problem was unsafe lithium chemistries. Now that problem has evolved into limited access to safe, reliable, affordable, and sustainable power. This has happened because energy costs are escalating everywhere, but also in the US specifically. The infrastructure is failing. You know, our transmission lines are really old, and the equipment as well, like the transformers, are often even older. They're just not designed to be handling the new technology that consumers are adapting, like EVs, for example. And EV charging happening at night is not allowing the transformers to cool down. They're overloaded all the time, and failures are occurring more and more frequently. This really is just highlighting the need for distributed assets, which is what we want to provide to customers. We want you to be able to take power over your power. Excuse the pun. Decarbonization is also increasingly being demanded by cities and utilities, as even the city that I'm living in right now, San Luis Obispo, they have a goal to meet 100% net zero carbon by 2035. However, there's a clear lack of path that a lot of cities just don't really have a clear path to meet those goals. So we're hoping to provide a solution to this issue, which is caused by the limited access to safe, reliable, and affordable power. Now, not only are we doing this in a variety of locations, but we're doing it in a variety of applications. So our batteries are used all over the world for peak shaving, time of use, and generally integrated solar plus storage. Peak shaving is when your utility company decides that they're going to charge you a higher rate when you use above a certain amount of power at any given time. And this can get really expensive if you're not careful. So in order to offset this, you can use batteries to kind of take care of any demand above a certain level. It's easily accomplished with several of the leading inverters on the market, as well as our batteries. Time of use rates. These are getting more and more common now. We're seeing them, the rates rise at different hours of the day and fall, for example, in the middle of the night when nobody's using power. By having batteries, you can buy power when it's the cheapest and then use it whenever you want. You don't have to worry about the time of use rates. And with integrated solar plus storage, batteries are always needed, in my opinion, because really you can see this is the green line is when consumers generally use the most power, the mornings and the evenings. But that's the opposite of when PV is producing power. So the sun's not out when you want to use the power, so you really need to store that energy in batteries. Now, to transition into an overview of battery chemistry, let's talk about why lithium iron phosphate is so great. Lithium iron phosphate has no danger of thermal runaway or fire propagation. There's no toxic elements. This is mainly due to the lack of cobalt. So Cobalt has a very high specific energy, means energy density. And when it gets too hot, it can essentially quickly release all of that energy. So in a thermal runaway event, a cobalt-based battery is just spitting out energy so fast as heat that it often causes a thermal runaway or even a fire. It's not the case with lithium iron phosphate. There's no cobalt contained in the batteries. The batteries also involve no abusive mining practices, as lithium, iron, and phosphate are all abundantly found. There's no ventilation, cooling equipment, or safety monitoring equipment required, and the lithium iron phosphate batteries are able to withstand high temperatures. Now I'm going to abbreviate lithium iron phosphate as LFP from here on out. So our battery has a lot of features and benefits over others that I want to talk about here. First, the form factor. So we've chosen the chemistry as lithium iron phosphate, but let's talk about form factors that are used to kind of build the battery. Cylindrical form factor, think AA battery, that is a cylindrical form factor. So it's got built-in short circuit protection and it's got an excellent lifespan. Pouch cells are often used in things like laptops. They're great, but they have a tendency to kind of swell and it's easy to puncture them. Imagine driving a nail through this would be like cutting a cake. Prismatic cells are great, but they're a bit bulky. So we've chosen cylindrical cells to be our form factor that builds our battery. This allows us to have the best performance and the longest lifespan. Another key feature of our battery, of course, is the warranty. So we've got a very simple warranty. It's 10 years flat, no matter how many cycles you use during those 10 years. And even after those 10 years, you're guaranteed to have 80% of the initial capacity remaining in the battery. So really, you're going to get a bunch of bonus cycles. Now, the 10-year warranty is not affected by how deep you discharge the battery. So you could actually discharge 100% of the battery capacity every single day, drawing it down to 48 volts and then back up to 56 volts when you charge. We're going to talk about charging set points a bit more later as well. Lithium iron phosphate batteries also have a very wide temperature window. So they can be operated, which means they can either be stored and rest or be discharged from -4 degrees Fahrenheit all the way to 140 degrees Fahrenheit. Again, that's for storage or for discharging. For charging the batteries, they cannot be charged below freezing or above 120 degrees Fahrenheit, but that is still a wider window than anything else I have seen on the market. This really helps us not need coolant, HVAC, or ventilation. PHI batteries also come with an integrated BMS that's internal to the batteries and a circuit breaker. So if you're not sure what a BMS is, that's a battery management system. It's going to balance the cells and provide overcurrent protection, short circuit protection, and charge and discharge protection. We did a very detailed training on the different types of BMSs in the different batteries that we offer and the advantages and drawbacks of each. The BMS here is internal, like it's inside of the battery, and the breaker here is accessible by the user. So when you're installing the battery, this is a really big advantage to have a breaker here. In my opinion, you can simply make the battery not live, so it won't be able to be short-circuited, and you won't have any live wires when you're doing an installation, for example. This is really helpful. Another key feature of our batteries is the C rate. So the C rate is the rate, it's a measure of the rate at which you can discharge a battery relative to its maximum capacity. So if you're charging a battery, or sorry, if you're discharging a battery in 1 hour, the whole thing in 1 hour, that's a 1C rate. If you're discharging a battery in 2 hours, that means you're discharging half of its capacity at any given moment, meaning you're discharging at C over 2. This is a relative rate, so as you add batteries to a system, this actually scales up as well. Excuse me, wasn't ready to skip forward there. For example, if you have one 3.8 kilowatt hour battery, it means you can discharge it at 1.9 kilowatts. But if you've got 2 of those batteries, that rate doubles to 3.8 kilowatts. In addition to having a high C rate, high power output, our batteries are also scalable and expandable. So what I mean by that is you can add as many as you want in parallel. It's just a simple wiring configuration. You're going to connect all of the batteries to a common bus point, and I'll show you more details on that later. There's no communication lines that need to be run, and really this is infinitely scalable for both energy storage and power demand. What I mean by expandable is that you can go back to an existing system and add more batteries later, years down the road. This is not something that I've seen from other manufacturers, so I really appreciate this about our batteries. So here's just some photos, for example, of a scalable system. System on the left is 80 batteries. That's over 300 kilowatt hours of storage. Now they're just wired all in parallel. So there's a big fat bus bar going over the top of the terminals. It's got 10 on each bus bar here at this airport hangar on the left. And then each bus bar also connects to another common connection point. So we'll talk more detail about wiring later as well. It's also easy to expand. And what I mean by that is, like you see here in this photo, this person started out with 8 batteries, and then they even added 8 more later down the road, doubling their capacity. Our batteries do not need maintenance. They are self-contained and stable, so they don't release any gases and they don't need ventilation. There's really no maintenance at all needed, unlike a lead acid battery where you'd have to do, watering, topping off, and even specific gravity checks. And a lot of times you have to kind of sit there during the equalization charge and check on the specific gravity. It's just a big pain. Low self-discharge rate in addition, especially when you're comparing this to a lead acid battery, this is a big advantage because often lead acid batteries kind of need to be kept on a float charge because they can lose capacity so fast just by sitting there. Not the case with lithium iron phosphate batteries. They have a discharge rate of 1% per month, and that's really an overstatement. I've seen it often be much less. So this is, again, an advantage if you're leaving your battery bank for a long time. Let's say you're leaving for the winter and you don't want to keep them charging because you're afraid the temperatures might drop below freezing. You can just leave them in storage and not worry about needing to charge them all winter. Here's an example of how it cleans up the bank. See here, there's 24 lead acid batteries. It's a 6x4 rack right there. Now, by replacing that rack with just 8 SimpliPhi batteries, we've increased the storage capacity and the power availability. Additionally, we've cleaned up this mess of wiring. You see a lot of corrosion here. Maybe even this battery looks like it's maybe gotten a bit too hot and melted the case. I'm not sure. And I believe these here are temperature sensors. So that the charger can temperature compensate the batteries. That's not needed on our batteries. Actually, it's not recommended at all. So it makes wiring a lot easier to not have to worry about those. Cool. So let's do an overview of some of our products. This battery here is our bread and butter. It is our most popular product. It's the PHI 3.8 kilowatt hour battery, available in both 24 volt and 48 volt. It's 151 amp hours at 24 volts or 75 at 48. So this is just going to be simply wired in parallel. Again, you can scale it to any size. You can parallel as many as you need. There is no limit. It was initially designed as a drop-in lead acid replacement. However, now we're seeing them used for all sorts of different projects. There's not any sort of limitation. It doesn't need to be a lead acid replacement, of course. And as we touched on, the integrated BMS and circuit breaker. This is our 12 volt battery. It's also available in 24 volts, but it's 1.4 kilowatt hours, making it small and lightweight at just 33 pounds. This is great for mobile applications, and it comes with a Anderson power pole connector or a bare wire connection if you prefer. This battery also has an integrated BMS, and it's compatible with generally a whole wide range of equipment like charge controllers and inverters. We're not super specific as long as you can meet the charge set points needed. That is the main concern. Going back real quick, one thing I wanted to point out was the weight of our 3.8 kilowatt hour battery. This is less than 80 pounds. So that means one person can carry in and out a bunch of batteries to a job site instead of having to rent, a crane or a forklift to drop in some giant system. Now moving forward to our expeditionary products. These are great for emergency response and even camping because these are waterproof enclosures. The Jenny units, and some of them even have the option to add solar panels. I see a lot of these still used today, and this is our same lithium iron phosphate chemistry and cylindrical form factor. Or express units. These are another great mobile solution. These are super customer friendly and installer friendly as well. I say customer friendly because you take it out of the box and it's ready to be used. You don't need to hardwire it into a panel at your house. You can just charge it up by plugging it into the wall. And you can discharge it by plugging your loads right into this little wall port here. It's also got 2 USB outlets, and it's got a DC quick connect inlet for your solar power. So I really like this. For example, if you're somebody who lives in an apartment in a city and you want to have backup power, and then you also want to take that backup power to your cabin, for example, out in the middle of nowhere. This is why this is great, because it's on wheels. It's almost like a little briefcase. This is another pre-wired unit. Here it's called our access unit. It's got industry-leading inverters inside, available in DC or AC coupled options, and great for new or existing PV systems. No maintenance, top-of-the-line safety, and it's a NEMA 3R enclosure. So this can be mounted, for example, to a concrete pad or just left standing. There's a lot of options here. We're going to go into detail about these later. But just a big advantage here is that, this cabinet's outdoor rated. When you're installing a lot of these systems nowadays, I see people wanting to put the batteries outside, especially in an AC coupled system. All the equipment is already outside, so you can just drop this in between the sub panel and the main panel. Moving to our high voltage solutions. This is more for commercial and industrial solutions, such as microgrids even. It's going to be able to provide 3-phase power by reaching up to 1100 volts DC nominal. Now, this is a bit different than our other batteries because the BMS is no longer internal. It's actually an external BMS, so it's a bit different, allowing it to scale to a higher voltage. It's also CAN bus, Modbus, and Ethernet ready for communications. And often these come in a containerized solution. So if you need something specific for project, please just contact us to get some more details on this. Again, my email is going to be at the end of this presentation. Our AmpliPHI battery, this is our newest battery that we've added to the lineup. It's the same basic specifications as the other battery, the 3.8 kilowatt hour battery. So it's 75 amp hours at 51.2 volts nominal. This is also UL 1973 certified. However, it's got a slightly increased max discharge here at 100 amps for 10 minutes. Now, the main thing you see different here is not only the white case, but the 3 communications ports. This means that this battery has closed loop communications with the inverter. Right now, it's approved to communicate with solar inverters only, but we're adding to that list very quickly. It's got, although it's only a few pounds heavier, it is the same dimensions as the Phi battery. This allows it to fit in any existing cabinets, access units, boss cabinets, as well as wall brackets that we have for our Phi batteries. Again, closed loop communications with the inverter. This allows you to monitor the battery's performance through Solarc's monitoring platform. There's no external cards required for this inverter integration. Nice and simple, just plug in the Cat5 cables and you are good to go. So what this communication means is it's going to allow the battery to auto-populate the most important set points. Like, we're going to talk about the set points on the next page, but you'll also be able to see highly accurate readings for state of charge, voltage, and current in and out of the battery at any given time. Another big advantage to this battery is it allows for flexible sizing. So this battery can actually limit its own charge and discharge rate by communicating with the solar inverter. So what that's going to allow you to do is if you have a customer wanting to install a solar inverter with just 1 or 2 batteries, you know that that's not possible with the Phi battery because of the C/2 rate. However, with the AmpliPHI battery, it can communicate to the solar inverter and limit its own charge and discharge rates. So you can actually start with just 1 or 2 batteries on that inverter and then increase as you go. The battery communicates its set points to the solar converter, like I said. So those set points are 37.5 amps DC and 60 volts DC for overvoltage protection. And it's going to have 2 lines of protection. One within the inverter, telling the inverter to, hey, please cut off charging when I reach 60 volts. That's the absolute maximum worst case scenario. Really, these batteries should be charging to 56 volts, and this 60 volts is just kind of a backup protection. It's also going to handle temperature, low and high. So if the inverter tries charging the batteries at low temperatures, the battery is going to open the circuit or reduce the amount of current going into the battery. So this temperature protection is actually handled inside of the battery itself. So even if you needed temperature protection with a different inverter other than the Solarc, that's still possible. So So I want to bring up one point here is the BMS is not some magical unicorn that's going to allow you to plug your battery into a wall and just use 120 volt power or something crazy to charge your battery. You still need to treat the battery how it needs to be treated. However, you know, the BMS is there as a line of defense. It's not the only line of defense, right? So the system still needs to be designed properly and sized properly. A BMS does not modify the voltage of the power going in or out or the current. It's just going to essentially open the circuit and stop providing power if it doesn't like what it sees. We did a very detailed training on BMSs, so if you need to find that, just email me. So to touch on programming and integration, the AmpliPHI battery is going to auto-populate these set points within the solar arc inverter. It's going to absorb at 56 volts and float at 54. The BMS is also going to communicate to the inverter its current state of charge and its remaining capacity. It's also going to disable temperature compensation through the inverter. So these three settings at the bottom are what you're going to need to program. So ultimately, you're just going to connect the communications, turn on the system, program these three settings, and then you'll be good to go. So some options for system layouts. You can get the solar access unit with AmpliPHI batteries in the unit. This is great because it's on all-in-one unit. It's already programmed and outdoor rated. Or you can get the solar arc inverter outdoor rated version, and you can put the batteries in a boss cabinet that would make them protected from weather. Or you can just leave the batteries inside and you really don't need an enclosure whatsoever. So now let's talk about levelized costs of energy. When we talk about LCOE, we don't want to just focus on the upfront cost of the battery, but more importantly, what is the cost of each kilowatt hour that you're getting out of this system? To calculate that, we can use this equation up top, but don't feel like you need to memorize this equation. We have a calculator on our website. One thing I just want to point out is the ancillary costs. Most people forget to consider these. When you're talking about installing the battery, if it's expensive to install or it needs to be maintained often, these are going to be huge ancillary costs that are going to add to the cost per kilowatt hour. If it needs to be replaced often, or if you need a forklift to install it or replace it, that's another big cost you're going to need to consider. Cooling, ventilation, all those things are ancillary costs that can really bump up the cost per kilowatt hour. So I'm going to show you how to use our cost per kilowatt hour calculator. Hang tight here while this loads. I'm going to do the comparison for our 48 volt battery. And let's just say we're paying $2,500 per battery at 80% depth of discharge. This is going to be recommended for the longest lifespan. That brings us to less than 9 cents per kilowatt hour. I have not seen that anywhere else on the market. We can compare the price to lead acid batteries or other lithium batteries. I'll briefly compare it to a lead acid battery at the moment. I had a sealed lead acid battery that I paid 360 bucks for. It was 12 volts and 200 amp hours, and I was using it at 50% depth of discharge. So I was paying well over 4 times per kilowatt hour. 40 cents per kilowatt hour, which is over 4 times the cost of a SimpliPhi battery. And that battery burned out pretty quick. So I didn't even consider the ancillary costs in here, such as installation. Luckily, there really wasn't any maintenance, but it certainly was a pain to replace. Let's go back to the presentation now and talk about battery sizing. So if you're off-grid, when you're sizing, you really want to look at the mode of operation. So if you're off-grid, you are going to be cycling these batteries daily. That means I would really recommend 80% depth of discharge. That's going to give you the longest lifespan. So when you're sizing your system, you want to take into account that, yes, there's 3.8 kilowatt hours of storage in this battery if I really need it. But on a daily basis, I'm going to try to use about 3 kilowatt hours, which is about 80%. Now, if you're just using these batteries as a backup for a grid-tied system, and it's really only going to come on during a power outage, in that scenario, you can totally get away with 90% depth of discharge, maybe even 100 if you want to push it. Another important aspect of sizing is matching the inverter. So you want to make sure that if you've got, let's just do an example, if you've got an 8 kilowatt inverter continuous, like the Radian, you want to have at least 16 kilowatt hours of battery capacity. So that would be 5 batteries, 5 PHI batteries per Radian 8 kW inverter. That's going to allow your batteries to provide that C/2 current to that inverter if it wants to draw 8,000 watts continuously. Just want to spend one more moment here to just stress how important this rule is. If you can get one takeaway from this presentation and you're installing our batteries, it's the C/2 rate. This is really one of the only places we see damage occur is when this rule is not followed. And to help make sure you always meet that rule, we've got these calculators here. This first calculator is going to kind of just take into account the bank size that you need to meet the loads of the customer. So if they want 2 days of autonomy, for example, and they want to run an air conditioner, it's gonna take that information and give you a battery bank size. Now the second calculator, this is going to take into account more system information like the inverter and charge controller specifications. This third calculator is really just for placing lead acid batteries with the same size or larger lithium battery bank. Cool, so let's touch on installation, my favorite part. If you're installing our batteries, hopefully you already know about this section of our website. If not, I'm going to show you. This is our support tab. So over here, you can click on any of these items and you'll find all the documentation you need to install our batteries. Spec sheets, warranties, manuals, and my favorite, integration guides. So let's say you just bought your Midnight Classic 150 charge controller and you want to know the settings. Just go down to the program settings for PHI 3.8 kilowatt hour battery. Here they are, plain and simple. And we've got an integration guide for most of the popular equipment brands that we know that are compatible. We've also got a support team here on deck, so if you have trouble finding those or understanding them, do not hesitate to give us a call or an email. And again, my email is going to be at the end of this training. A few more installation tips here. Mounting. We want to make sure that the batteries aren't mounted directly resting on top of each other and then they're not mounted upside down. Aside from that, there's really no clearance or spacing requirements at all. You can use our boss cabinets, our access units, or our wall brackets, or you can custom make your own cabinets. I've lately been seeing a lot of installers make some really cool custom cabinets. Always love to see that. Send us your photos if you got any. For wiring, you want to make sure that you're wiring all the positive terminals to a positive bus point, and then the same with all the negative terminals. Additionally, you're going to want to use the same size, same gauge wire, and same length wire on each battery. So if this run is 4 feet, then this run is also going to be 4 feet. The minimum you can use is 6 gauge, but really I've seen almost everybody use 2 gauge or larger for the most part. And when we go back to these bus points here, a great option to meet that need is a combiner box. So you can have all the batteries meet the cables from the batteries meet inside this combiner box. Now, if you're doing an outdoor system, this midnight combiner box is a great option because it's outdoor rated. But if you're doing it inside, you could just use a basic bus bar if you prefer. You can even custom design your own power panel or bus bar. But something I like to point out is that if you're using an inverter, let's say you have an XW Pro 6848 from Schneider, you can just get the mini PDP with the Schneider. It makes it so much easier because you can just combine your batteries in the PDP. So I'm going to show you what that looks like in a second here. First, we have a system example where you can use the Midnight Combiner Box to combine boss cabinets full of batteries and then take those batteries and power a solar converter. Just one example of how you can combine the batteries. And within the boss cabinets, you can also use the 3 battery bus bar kits to make for less wiring. Those bus bar kits would then be combined here on this terminal block that's included with the cabinet. This is the example that I was talking about with the XW6848 Pro. So you can actually just combine the batteries or the boss cabinets right here in this mini PDP. I think that the mini PDP has either 2 or 3 landing spots for batteries. And when you're tightening down the nuts on the terminals of the batteries, make sure to use a calibrated torque wrench, not a socket wrench. I've seen too many people recently forget to calibrate their torque wrench or just over tighten using a socket wrench. I've even seen a couple of people snap off a terminal. In my opinion, you'd have to really be going way too hard to do that. It's pretty easy not to do that as long as you're using a torque wrench. When you're commissioning the system, some programming that I want to go over. 2-stage charging. That is great for an AC power source like the grid or a generator. One thing that's really important, you don't want your generator to be hanging around on and running just to float the batteries. That's just a total waste of fuel. And you're going to end up with angry customers if you forget about that. Now, 3-stage charging, meaning you're adding on that float stage. So bulk, absorb, and then float is the 3rd stage. That's great for when you have a PV system, for example. If you've got a DC source that's kind of just going to, the solar's going to go to waste if you're not using it to float the batteries, you might as well float the batteries. They're not going to mind. It's going to keep them nice and full. And so also, here are just some examples of settings that are important. Low battery cutout, high battery cutout, bulk, absorb voltage, float voltage, and battery capacity. So these are going to help your system treat your batteries as they should be treated. So I promised you some more details on our access units. So I'm going to go into that. It's a pre-wired unit. Internally, all the connections are made except for the battery connections. So after receiving this, you'll just have to pop the batteries in the cabinet and put on those cables onto the batteries. The rest of the wiring is done for you and it's delivered crated. The inverter is also mounted inside the cabinet. There's a few options for AC or DC coupled. There's also knockouts on the side of the unit. It's hard to see here, but they're around this area for you to parallel multiple, add boss cabinets to an access unit. So add storage to the system or to wire it into your house. This is the Schneider option. So it comes AC coupled standard with the 6848 Pro and the PDP. If you want to add the Schneider 600 volt MPPT Connext charge controller, you can do that as well for a DC coupled system. This is great because it comes with monitoring, real-time monitoring as well as historic monitoring. So you're going to not only be able to see the amount of amps going in and out of the battery and the voltage at any given time, but you can also go back and see the behavior of the system on any day you wish. You can even give your end user access if you're the installer. However, you cannot wirelessly program this system. The SolArc you can wirelessly program. I actually just did it yesterday and it wasn't so bad at all. This is a 12 kW inverter. Its continuous output is 8 kilowatts of battery power, but it can also take in more solar PV. So that's why it's a 12 kW inverter. There's 2 MPPTs built in so that this unit can do AC or DC coupling as it comes with no added components. It's also capable of rapid shutdown with one button, can disconnect the batteries, inverter, and PV. If you have the Tigo modules, for example, and a normally closed button, I believe, for the SolArc. And it's capable of self-consumption and time of use if you're wanting to be self-sufficient or avoid utility charges. The SolArc access is also available with AmpliPHI batteries that are going to have the closed-loop communications. It's going to give you high level of accuracy of readings for state of charge and voltage and charge and discharge at any moment. And like I said, this does have the ability for wireless programming. You can, for example, as the installer, have the access to the programming, but then give your customer access to just view the system. Really nice monitoring. And also, I've been really happy with SolArc's customer support as well. As you know, we've got people on the phones here and answering emails. SolArc definitely does as well, and they're doing a great job. So I really appreciate that. Just a quick diagram of kind of an AC coupled versus DC coupled system. In an AC coupled system, you've got the PV array going through a charge controller, which is going to moderate the voltage and current to treat the batteries. That charge controller is connected right to the DC bus. So you've got DC power all the way from the roof to the DC bus. Whereas with an AC coupled array, comes off the roof as AC power. You've got probably a micro inverter, maybe a string inverter, converting the PV modules to AC power, then going into the sub panel, which connects between the loads and the inverter. Now, adding a generator is very similar to AC coupling. Cool. So lastly, before we wrap up, I want to also talk about our IQ installation program. Give me just a moment here. So our IQ program is really helpful for people who are installing our batteries. As an installer, our IQ program is going to allow you to highlight yourself through our marketing. So it's basically free exposure. We've got this new IQ newsletter going out, and I can tell you that all the attention is on the featured installer. So if you want to be featured on that newsletter, you should apply for IQ. This is also where we're sending anybody who needs to find an installer for our batteries in their area. We tell them, hey, go check out our where to buy map, and you can see all our IQ installers there. As a distributor, you should encourage your installers to get on board right now, because it will demonstrate that as a distributor, you have an increased knowledge of our products, and it's also going to boost your SimpliPhi sales. Lastly, it's going to show distinction over other installers by giving you access to our logo and branding. So if you're already installing our batteries, this is a no-brainer. It takes about 5 minutes to complete the application. It's right here. You can just click this link and apply. Be sure to submit photos of your installations if you have them. We'd love to see them and we'd love to feature you. Well, that's the end of my content. I want to first say thank you everybody for attending, and now I'm going to go ahead and jump into the Q&A. Does the BMS have high and low temperature protection? So the AmpliPHI BMS has both high and low temperature protection. It will not allow you to charge the battery below freezing, and it will not allow you to charge at too high of a temperature. The PHI battery does not have low temperature protection, so it could be damaged by below freezing charging. You want to make sure that you do not charge the PHI battery below freezing. Hey, I see a hand raised. Just please put in a question and I'll answer it as soon as I can because I can't unmute you. What settings are you using on the Magnum router to accommodate proper charging of your system? So hopefully you found where to see those settings. What you're going to do is go to our support tab, which was earlier on in our presentation. There's a link to our support tab. You're going to go to the integration guide. That way you can find all the settings for the battery. Generally though, we're going to absorb 56 volts for 6 minutes and set the low battery cutout at about 50 volts. Please have someone contact me with respect to your containerized solution. I'm presently quoting a job that would require 100 to 200 kilowatts of solar input and 1 to 2 megawatt hours of storage. This sounds like a great opportunity for the high voltage solution. Just go ahead and email me at training@simpliphipower.com. It's really hard to keep track of everybody's contact info during this presentation. So if you need a follow-up, just email me here. As I said, it's going to be hard to write down everybody's contact info right now while I'm answering questions live. So please just email me. Sorry if I missed it. Will you be able to share a recording of this presentation? Yeah, absolutely. Everybody who's signed up for this is going to get a recording after the fact. It might take 1 to 2 days to show up in your email, but as soon as it's edited and ready to go, we're going to send you a link to the YouTube video. Are SimpliPhi products available in West Africa? Yes, they are. Check out our where to buy map. And if you can't find a distributor, just give us a call and we will be sure to find somebody who can ship batteries to West Africa. I want to specifically provide grid support to my local utility, and I expect more frequent but shallower depth of discharge cycles each day. Are LFP chemistries as applicable for that? Yeah, absolutely. You don't need to discharge them any certain amount. It's just that you can discharge them up to 100% if you need to. Absolutely, they'd be fine for that application, totally. However, for your higher voltage applications that you're mentioning, note that our batteries cannot be wired in series unless they're the high voltage line. So our standard PHI batteries and AmpliPHI batteries, those are not going to be able to be wired in series at all. How many batteries are included in the SolarArc access unit? That comes with 6 batteries. I believe there's also an option for 4 batteries. but the 6 battery unit is far more popular. I have a microinverter system of 3 kW on my house. It's about 8 years old. Can I add your backup power system to it instead of the manufacturer's new solar plus storage offering? Yeah, absolutely. I'd say to email me with a few details of your system. That way I can, help you design the right system, the right size and equipment. But absolutely you should be able to really add any type of battery as long as you have the right inverter. So let's get some more details on your system, but I definitely think that our batteries should be able to work for that. How are the express units grounded? There's no need for you to ground specifically, each battery. I know there's kind of growing concerns about how to ground metallic components, like maybe the case, the enclosure. So that would be up to you to just go ahead and create a little grounding lug and ground that however you please. They are a floating ground. Can we have your email for NABCEP credits? My email is at the bottom of the screen, training@simpliphipower.com. Shoot over an email with your full name if you need NABCEP credits, please. Is the 3 battery bus bar kit sold through your company? We do have a 3 battery bus bar kit. However, we often, we really don't sell direct. We sell through our distribution network that helps us keep prices low and lead time short. So if you do not have a distributor, just contact us and we will get you in touch with one near you. Make sure to let us know your location first. Revisit the torque info, please. 160 inch-pounds is the torque value. Excuse me if I messed that up. I may have said foot-pounds. It is 160 inch-pounds. Setting to 6848 XW plus. Not sure what you mean, but if you need the settings, they are under our support tab in the Schneider integration guide. How much is the life expectancy of base battery model? It's 10-year warranty on our 3.8 kilowatt hour battery. At the end of the warranty, you'll have 80% of the capacity remaining. Thanks for the kind words. Thank you for coming. Following up on tapping into a microinverter system, does that mean bypassing the microinverters with one new inverter and no longer having panel by panel monitoring? No. So when you're adding batteries to a AC coupled system, you need a battery-based inverter to take that AC power and turn it into DC power to charge the batteries. So you're just going to need to make sure that your battery-based inverter and the microinverters on your roof are compatible. So really, let's say you've got the N-phase inverters and you want to add an XW Pro, just going to want to call up Schneider as well as N-phase and just make sure that those 2 inverters are going to work well together. How long does the Elite IQ installer program take? The application takes about 5 minutes at most, I would say. If you're already installing our batteries, it's really a no-brainer. The requirements to be a distributor of your batteries. If you are looking to become a distributor and you're selling many batteries per month, I would say contact me and I'll put you in touch with our sales team. I'm not totally sure about those requirements, honestly. Excuse me here, just reading kind of a longer question. When you're using a battery rack of ours, we can't use a bus bar. So I think you're probably referring to the wall brackets. It might be hard to use a bus bar when you're using the wall brackets, but you could just use a combiner box instead and then have the same length, the same gauge cable connecting each battery to that combiner box. Do we have any presence in Europe? Yes, absolutely. We've got distributors in Europe, many systems installed there as well. The chart says no toxic elements, but in a recent solar video, someone has a big LFP battery that is leaking electrolyte. Isn't that toxic? That's a really good question. So there's no toxic elements that go into creating the battery from scratch. I do believe that electrolyte would not be safe to touch. I wouldn't want to be inhaling the fumes around it if it was leaking. However, I've never really seen electrolyte leaking, and it's going to be pretty obvious if it is. So that's really not something that I would be concerned about. There's no toxic elements by you just being nearby the battery. For example, with lead acid batteries, they're constantly venting potentially toxic gases, and they're constantly venting flammable gases. Those need to be vented to prevent any sort of buildup. Awesome. So that looks like all the questions. How does it work with rapid shutdown with a DC system on a roof? That's a good question. I'll talk about that for a couple seconds here. DC systems have the ability to accomplish rapid shutdown by using the TIGO TS4-F modules. So those can go on every module or every 2 modules. And there's also a transmitter that will transmit a signal to those shutdown units to turn off when you power down the transmitter. So there's a lot of ways you can accomplish that, but I would say check out TIGO's website and check out our safety and standards presentation if you want some more info on that as well. Awesome, guys. So again, this presentation will be sent out, a recording to everybody who signed up, and we are going to send out that link in just a day or two. Also on our YouTube channel is a bunch of our other trainings that get more specific on a lot of these topics you're asking questions about. So definitely check those out. Thanks everybody for coming. Have an awesome rest of your day, and I'll see you next time, hopefully for the midnight training on March 9th. See you later.